Using Blendercam to set up some really good 3D carves for my CNC machine. We'll start off here with the default file. Go ahead and delete the objects here. And whenever I'm doing CNC operations, I like to set up Blender for my for smaller metric objects. So I'll go ahead and start by doing that. I'm going to go down here to Scene Properties and Units. It's in metric. I'm going to go ahead and change this meters to millimeters. Now I'm going to go up to the top right to Overlays, and the scale for the grid, I'm going to go ahead and swap that to 0.0001. That's 1 millimeter per grid line. That's going to make whenever you zoom in, you see the mesh will start to kind of clip that view. So I will go over here. You can press N to bring out this menu. You'll go to View and Clip Start. Let's see, let's zoom in some. Clip Start, let's try 1 millimeter. See, there we go. Now we're set up for smaller objects. And that should do it for the initial interface setup. So we're ready to go ahead and import our model. I'll go to File, Import, and STL. And I'm going to select this file right here. You can't see it on the recording, but my little file picker interface is pulled up. Here we go. And I found this one on Yegi. No, not Yegi, I'm sorry. My Mini Factory. It's by an artist named Paul Palmer. It's the Duke himself, John Wayne. You can find these STLs anywhere. Just Thingiverse is a popular one. You have Yegi.com, another great one. So, okay, STL files import into Blender. Really, just way bigger than you would think they should be. I'm not sure why. This one's 74,000 millimeters across. We're going to go ahead and just hit S and scale this down so I'm getting closer to the size we're looking for here, which is oh man, let's see, probably about 100 millimeters across. Let's keep bringing it down a little further. Yeah, about right there for now is good. I know that my my material is about 130 millimeters by 200 millimeters in dimension, so that's good for now. So next we'll go ahead and go into our render properties. We're going to swap that render engine to cam. We won't be making a cam chain today, but under cam operators, this is where we'll be adding our operations. I'm going to control click on that just to minimize everything else. I'm going to go ahead and set up my machine first. So under machine, let's see, my post processor is GRBL, and I know my work area is 268 millimeters. Something's wrong here. Okay, whenever you enable Blendercam for whatever reason and you start messing with the machine, I've noticed that you'll actually lose your unit definition over here. See, look, it went back to meters under Scene Properties. Looks like after you swap it back to millimeters one time, it stays after that. I'm not sure what that's about, but it's not a big inconvenience. So now back to the cam menu. 268 millimeters, and my y-axis is 318 millimeters. And what the heck? What? 318 millimeters. There we go. Alright, hit enter instead of tab that time. And I know that my z-axis is 32 millimeters. I don't have a lot of z height. You'll see it kind of interferes later. I have to make a few changes. Go further down. No fourth or fifth axis. My spindle speed, I pretty much operate at 10,000 all the time. I'm using the Same Smart Genmitsu Prover, whatever, I don't know. And The default is 10,000. That's the max you can run at anyway. Alright, so that's done. Okay, now we go ahead and start setting up our operation. Let's see, if you look though right here, you should be able to see the machine. There it is. Alright, so there's my machine dimensions right there. Okay, going up to the top here under CAM operations, I'm going to go ahead and add the first operation. I like to make sure that collection is selected right here. Blendercam has some funny behaviors when it comes to collections, so I wouldn't go adding my own collections, and make sure that you have that main one selected whenever you do a lot of things. Anyway, you might see what I mean later. So operations, I'm going to add an operation. Alright, operation 1. The name, I'm going to call this one profile because we'll be profiling it out, cutting it out. Okay, source of data will be an object, and the object will be this John Wayne bust. I've never really used simplified Gcode. Alright, going down further, check out cam info and warnings. Nothing yet, no warnings, nothing's going wrong just yet. Cam material size and position, here we go. So I don't estimate for model, I just never have. I've had better luck putting in the material size manually. So under material size, my material is 130 millimeters by 200 millimeters on the y-axis, and it is 19.5 millimeters thick. Go to position object, and I'll click it, and all this is going to do is just place it on the material, and I believe it sets the origin of the object to the very tip right here. Let's find out. Yeah, location Z0. Okay, it just places the very top of the object on the top of your material, Z0. So that's all it's really doing there, and then I can grab it. Let's look here, and I can position it on the X and Y axis, just kind of in the middle of my material. Let's see, grab, not on the Z axis. Go over here, yeah, about right there. Looks good. I don't need it to be right in the middle because I will be cutting it out. We have the material size and position set up. Everything looks good. I guess it's a good time before we do the operation setup to discuss what I'm actually going to be doing. I'm going to have a profiling operation that's going to just basically cut this out, just around the entire silhouette here. So I won't be keeping any of this outside material. It'll just be cutting that out. I will leave these little bridges, little tabs, as it's called in some software, to keep the model from breaking free from the rest of the material. Just little bitty little sections that aren't cut out that I'll have to manually cut out once the CNC machine's done its work. And I'll have a roughing operation. I'll go over with a large bit and cut out a majority of the material, but it won't be a very detailed operation. And then I'll swap it out, my bit, for a smaller bit, a 0.5 millimeter ball cone bit, and it'll come back and it'll do one final finishing pass across everything and add all the detail. So it's going to be 3 operations. I guess this will be a good time to go ahead and scale our model on the Z-axis. So obviously, this is way too thick. Our material is only 19.5 millimeters thick. If we were to do it like this, we would pretty much have the brim of a hat and a nose. And a lot of the things on the back, they're not going to carve anyway because your machine's coming in from the top. It's just a 3-axis machine. It's not going to carve a lot of things, back of his head, things like this won't show up anyway. Let's go ahead and look at it from the side here. There's the top of my material. There's the bottom of my material. We're going to scale it on the Z-axis. Bring them up. Yeah, we're going to flatten them out a good bit. I like to get a good bit of that ear, looks like. Okay, and none of this down here will be carved, obviously. From here on up will. Oh, I'm wrong. So this, let me click on it. That is my material right here. I still need to scale this further on the z-axis, so we're gonna have to flatten them a good bit. Alright, bring his ear just up above that material. Okay, yeah, this is the machine here. Here's the material. Alright, so that's what it's going to be looking like. Like I said, we're doing a profiling operation. It's going to be cutting it out. So under cam operation setup, we have 3 axes. Axes, yeah. Under strategy, this will be a profile, a cutout. I'm going to do something different here though. To generate these profiles, these cutouts, Blendercam uses something called Shapely. And if you take a look here, let's tab into edit mode right quick. A lot of these imported STLs and sculptures from Thingiverse, and wherever you may get it, they have a lot of geometry. There's a lot going on there. A lot of vertices, a lot of faces and edges. Let's see if I can find. That's not it. Here we go. Statistics, just to show you. This one has nearly 1.1 million edges, 363,000 vertices. It's and Shapely, this Shapely has a lot of trouble generating a silhouette for these types of operations out of models that are that, that, what's the word I'm looking for, intricate. What I'll do while we're in edit mode, no, we have to tab out of edit mode. I'm going to go ahead and select my object. I'm going to hit Shift D to duplicate it. I'll hit enter to place it right where it is. We're going to hide the original for a minute, and we'll go to this copy. I'm going to rename it just to keep from being confused here. John Wayne bust decimated. I'm going to go ahead and decimate this object, and that means I'm going to tab into edit mode. I'll go over here to mesh. I'll go down to cleanup and decimate geometry. And what this is going to do, it's going to try to it's going to reduce the amount of geometry in this model while trying to keep the same shape. And I've had good luck with about 25%. So change the ratio from 1 to 0.25. Hit enter on it, and it doesn't take very long. It should calculate, and we'll go from 1.1 million vertices, you saw that, to 272,000 vertices. That's a lot better. Alright, let's tab out of edit mode, and it actually doesn't look that much different. You may be able to do the entire operation off of a decimated version. I've never tried. I'm not going to try now, but maybe sometime. Alright, with this object selected, the decimated duplicate, I'll go over here to the side. Okay, you have to be in object mode for this to come up, and it'll be minimized. I just kind of stretch it out with the object selected. I'm going to go ahead and click Object Silhouette, and it's just going to take a few seconds, and it's going to generate a silhouette. And your computer may be able to handle just making a silhouette from the original. Mine, it takes, I've had it take like an hour before. I've had it crash before, so that's why I go ahead and I decimate a duplicate to create my silhouette. Alright, not bad. It took about 45 seconds. I no longer need this decimated copy, so I can select it, X, and delete it. And now I have this silhouette right here, and I'll show you what this silhouette's going to be for, but I am going to generate one more silhouette for later, and you'll see why. So with this silhouette selected, I'm going to create a silhouette offset, and that means to create another one, but offset from the original. 3 millimeters looks about fine to me, so there we go. There's our original silhouette. There's our offset. I'm going to go ahead and rename this one just silhouette offset 3 millimeters. Go ahead and hide it for now. So we'll bring back the original Duke bust. There he is. Okay, we have our silhouette. Now let's go up to cam operations. We're going to change this. The object that it's based on will be the silhouette itself and not the model. Okay. Cam operations setup. So the strategy will be profile. The cut will be along the outside, not the inside of that silhouette. If we continue down, I don't really use any of that. We will be using bridges. Let's go ahead and auto generate bridges. So I'll select that. Whoa, that was quick. Okay, so bridges are going to be little pieces of the carve that Blendercam is going to ignore, and it's just going to leave material there, and that's just to go ahead and kind of hold the hold the carve in place, not let it break free while it's being cut. Let's go ahead and hide this again for a second, and this is where we created the bridges. I'll go ahead and select use bridges. Width of bridges, I like to play it pretty safe. I'm going to go like 4 millimeters wide. Height of bridges, let's say 1.8 millimeters. You may be able to change it up a little bit, to your needs. There we go. And let's just take one more look. So we have a bridge here, there, and there. Is that going to be enough? I think so. Kind of 2 on each side. Alright. Like I said, I go back, I select collection, don't select bridges, or whenever you generate a path, it may end up in that bridges group. So going down here, use bridges. Alright, cam optimization. This is just a profile. It doesn't even show you the option to use open cam lib. Everything else looks fine. I don't really mess with any of that. Cam operation area. Okay, so we are going to check use layers here because it's going to have to cut into the material pretty deep. Using layers, I like to use around half of my bit width, and I know that my bit width is 3.175 millimeters. We're going to divide that by 2, and there's my step down. Depth from object. Alright, so moving down to cam movement, I'm going to leave all of this alone. And cam feed rate. Okay, your mileage may vary. On my machine, I know I can do about 850 millimeters per minute, not 8,500. There we go. My spindle RPM, as I said earlier, is 10,000. Alright, cam cutter. We will be using an end mill. The cutter diameter is 3.175 millimeters. That's pretty much all I need to do right there. Gcode options. So I'm using GRBL, so I need to put an output Gcode trailer of M5, which shuts off my my spindle when I'm finished. Cam machine, we set that up earlier. Everything looks good. I think we're ready to go ahead and generate this operation, or calculate this operation. Calculate path and export Gcode. Give me a second. I'm going to pause this and figure out what went wrong. Okay, so what had happened, I forgot. So this is the object, right? And it is placed at Z0 up here, right? This is the object that we're basing the operation off of. And down here, I had under cam operation area, I had depth from object selected. Well, the object is Z0, so I calculated that path at Z0. which meant, hey, don't cut a thing. So unselect depth from object, and we're going to go to depth from material, this being your material right here. Why can't you highlight that? Anyway, material. So now we can go up here, calculate path, and export Gcode, and look at that. Alright, so everything looks good. We're starting off at Z0, working our way around this silhouette, taking about 1.5 millimeter steps down, and you see it mines the bridges here. It skips over right there. Like I said, those bridges, they'll hold the model to the material while it cuts. That operation looks good. We're going to move on to the next one. The next operation I'll set up is a roughing operation. So I'll go over here. Let's just kind of hide that profile operation for a minute. Let's go ahead and bring the Duke back. There he is. What I'll do, I'm just going to go ahead and copy this profile operation, and I'll rename it to roughing, and the file name that it exports as will also be roughing. The object, we're going to swap it back to the John Wayne bust, which will be right there. Alright, moving on down. Cam info and warnings, everything looks good right now. Material size and position, that's one of the reasons that I copied the previous operation. All that's already there for me. Looks good. Operation setup, so this will no longer be a profile. We're going with parallel, and parallel just means that it's going to sweep across left to right across that x-axis. So we keep going down here. Now we have a distance between toolpaths because, like I said, we're going to be sweeping left to right, and 1 millimeter. That seems good, about 30%. I might go a little bit higher. Oh, there we go, closer to 40% of my bit. This is a roughing operation, so I'm not too concerned about the quality of the cut, as long as it's as long as I don't damage anything really. And I'll be using bridges again, the same bridges from the last operation. Going down here. Alright, skin. So we are going to be leaving a skin 0.5 millimeters, and what that skin means is that we will it's not going to cut to the model itself. It's going to leave about 0.5 millimeter for that of material for that finishing operation to come and clear out and add in all the details. So we're definitely using a skin on this. Moving down to cam optimization, I do want to use OpenCamLib. Always have. It may work well without it, but I've always used OpenCamLib. It was part of the installation guide, so I'll put it in there. Cam operation area, we are using layers again. We're going to keep the step down at about 1/2 of the bit diameter, and we're going to use a limit curve. And no longer a depth from the material on this one. We're going to go with depth from the object, and that means it's actually going to use the object as opposed to the material depth, and it's not going to go below the material though. You'll see what I mean when it comes up. And we are going to use a limit curve because otherwise this parallel operation will cut across the entire material, and it would be cutting all this down, to the material thickness all the way down. But we don't really need that because we're going to be cutting this out, right? I don't really care if this gets cut down, so I'm going to use a limit curve, and that's going to tell it only operate within the bounds of that curve. And the curve that I'm going to use is this offset silhouette, the larger one that I made earlier. So limit curve, let's see, offset 3 millimeter, That's selecting this one right here. So now the operation will only operate within the bounds of this curve. It no longer cares about this remaining material out here. So moving down to cam movement, I like meander zigzag. That just means that it's going to cut going both ways, left to right, right to left. That works well for me. Free movement height. Did we change this on the last operation? I'll have to go back and look on the profiling operation. It looks like we didn't because we copied it over to this one, right? I need to go change that. So 10 millimeters for my machine is too high. It actually will hit the Z limit switch and mess up my operation. So I'm going to swap this to 3 millimeters. That may not be enough for you. That's just the clearance, right? That's just whenever it's making a fast move, a fast travel move, it'll go 3 millimeters above your material, go across and down. At least that's what I think it is. I'm still new to this, but I know if it's too high, it's going to go up and hit my Z limit switch. And actually, let me go back. No, we'll finish this and then I'll go back and change it on the profiling operation. Moving down, where was I? Meander zigzag, 3 millimeters. I'm not sure what any of that is, but cam feed rate, I want to keep it where it is, about 850 millimeters. Let's see, moving down to cam cutter, should be the same cutter from the previous operation, 3.175 millimeter end mill, good. Gcode options should be the same. I have my M5 at the end to cut off my spindle, and of course the machine still there. Alright, everything looks good. We'll go up here to cam operations. Let's save this right quick. You can't see the menu, but I'm saving it. Yeah, save often, especially on Blendercam. Every now and then you'll have a crash. Not often, but yeah, it will crash. Alright, calculate and export Gcode. Let's see what happens. Okay, everything looks good. That is the toolpath for my roughing operation. Come out well. It looks like it minded the bridges there. Everything's alright, yeah, it skips the bridges. It leaves about a 0.5 millimeter of skin. You can kind of tell. It's hard to see it, but I can see that it's leaving that little 0.5 millimeter of skin for the finishing pass to come back and handle. The only thing I don't like, I forgot to change. My machine moves a little bit better on the x-axis for whatever reason. So you can see right now it's most of the operations done on the y-axis. I'm going to change that, and to do that, let's go over to operation setup. Here we go. Angle of paths, it's set to 0. I'm going to swap that to 90. That just means 90 degrees left to right. I suppose you could do 45 and it would go corner to corner if that's something that you would do. I don't know. Anyway, I like 90, so I'm going to go ahead and pause this and recalculate it. Okay, much better. Now it's going, you can see it, the parallel operation going across the x-axis instead of the y-axis. That looks much better to me. And there's a bridge, everything came out just fine. Okay, good deal. That is the roughing operation. Okay, next up is the finishing operation. Let's go ahead and hide that toolpath. Okay, finishing operation. What I'm going to do, go ahead and save. What I'm going to do is go to roughing, and I'm just going to copy that one. Like I said, I like to copy as many of the settings down as I can. So click this to copy, and I'll change the name to finishing. The source of data should be the same object. Yeah, the John Wayne bust. Going down, just go through, no warnings yet. Material size copied from the last operation. Everything looks good there. Operation setup is going to be parallel again. The distance between the tool paths we're going to come back to that. I will be changing that. This is a finishing operation. So yeah, distance between toolpaths. Okay, we'll come back and change that. Use bridges. We're still going to use the same bridges. No, nothing changes there. Like I said, all this is already there because we copied the previous operation. So everything looks good. Now skin, we're going to leave 0 skin here because now it's time to go ahead and cut to the model itself. Right. This is the finishing pass. Cam optimization. Use open cam live as checked. Good. Cam operation area. We no longer need layers because all of this has been cut out by the previous roughing operation. So now we're just going straight down to the model. So we no longer need a layer or layers. We're going to keep depth from object. Limit curve. We're going to keep that same limit curve from the roughing operation. If you don't remember, that's just the bounds within this operation will operate. So keeping that. Moving down to cam movement. Meander zigzag, again, I like that. It seems to work fine for these 3D reliefs that I've been doing. Free movement height, 3 millimeters for me. Like I said, you may have a little more clearance. You may have some sort of clamps that you need to skip over, get past. But for me, 3 millimeters works fine. Moving down. Still no idea what a lot of these things are, but cam feed rate. I've noticed that I can go a good bit faster on my finishing pass. So I do 1250. You may not be able to go that fast, or you may be able to go faster depending on what you have. And here's another thing that's going to change: the cam cutter, the bit itself. So I'm no longer using an end mill. I'm going to a ball cone, and the ball radius on mine is 0.5 millimeters, and the V-carve angle on my ball cone, I had to look this up as well, 4.16 degrees. The cutter diameter, that's the shank diameter, is 3.175. Yeah, and it's complaining that our cutter engagement is greater than 50%. It should be, yeah, 250%. Like I said, we were going to go back up to that, and we will in 1 second. Cam Gcode options, we have the M5 for me because I'm using GRBL to shut off the spindle. Alright, machine, everything else has stayed the same. Distance between tool paths. So 0.5 millimeter radius. Let's see. Yeah, we want it to be pretty fine. Let's try 0.2 millimeters between tool paths. That gives us a cutter engagement of 40%. Let's go a little bit lower. We'll try 0.15, and this is just like the resolution of the tool paths. How many passes it makes, if that makes sense. So 30% of that tiny bit, that should be good. Something else to mention real quick under the cam cutter, this ball cone that I'm using, the actual the depth of the cutter itself is 15 millimeters, which, if you remember, I put 19.5 millimeters for my for the thickness of my material, and that's right. And I'm actually doing something somewhat unsafe. You shouldn't do this. You should probably go with a better bit, longer bit, or a thinner piece of material. I'm having to extend my bit a little bit further out of the collet. I hear that can actually, be a safety issue. So if you're wondering, that's why those numbers are off. But I don't recommend doing that. I'm actually going to have to find a longer bit in the future. Yeah, I think we're good to go. I'm going to go to cam operations. Let's go ahead and save this and calculate path and export Gcode. And this one takes a while. This is a very precise operation, this finishing one. I'm going to go ahead and pause it. It may take 10-15 minutes on my machine. Okay, we're still calculating, but I just wanted to bring up, I do like to run this with an open console, just so I can kind of see what's going on, see the progress. It's been calculating this particular operation for about 8-9 minutes now. Like I said, I have kind of a slow computer, but it just kind of lets me know the progress. And also, if I have an error, instead of a quick little window popping up and going away, I can open up my my terminal and look at the error and really read it and see what's going on. It's helped me out quite a bit. So just a little pointer there. Oh, looks like we're nearly done. Oh no, we got to do this part. Okay, still going. I'll I'll unpause once it's finished. Here we go. Take a look. Whoop. Let's highlight it and take a look here. Looking good. That's our tool paths. Sweeping along. Like I said, it's just one, no steps down, or layers as they call it. That looks good. Beautiful. All right. There is our finishing operation. All right, I have everything set up. I'm gonna go over to my Smart Genmitsu. I apologize for the mess. Wait, no, I don't. This is my damn shop. I don't apologize for the mess. I live like this. Okay. So, got everything set up on my Genmitsu. I'll go ahead and hit play on CNCJS. And let's see what happens. Should be good. Might be going a little bit too fast. I'll keep an eye on it. Yeah, I'm going a little too fast. I'm going to slow it down. There we go. Alright, so the finishing operation is just going to go over and hit that top 0.5 millimeter layer. Remember, we left a skin in the roughing operation, and this is going to go over about 0.15 millimeters per pass and just clean up everything and add the detail. Okay, if you're paying attention, you probably realize that I forgot to do the cutout step. I guess it wasn't really even needed, but that cutout operation did it showed how to generate that silhouette, and that does come in handy because of these really complicated models. Shapley has trouble creating a silhouette. It can crash Blender. Yeah, I'm a little tied up, I'm a little preoccupied. I'm building a station for my new long mill CNC. Pretty happy about that. All right, so this should wrap up in the next, I don't know, hour or something like that, and we'll take a look at it. Okay, so here we go. Looks pretty good. This dark spot by the eye, that's just a defect in the wood. This is cheap Home Depot hobby wood, so that's gonna happen. This up here, I'm not sure on the hat. It looks like it would be, you know, dented or whatever, but no, it's smooth to the touch. I don't know what's going on. I might try to wipe it out with some mineral oil or something. But anyway, yeah, Blendercam is great at making 3D relief carves. It's a great tool. I've looked at a lot of the other tools online, and some of the like the free online ones, you don't really have enough control over what you're doing, and the good ones that give you the kind of control that Blendercam does give you can run, you know, $300 to $700. So yeah, Blendercam is really awesome. You should give it a try. All right, thank you. Bye.